Hi everybody and welcome to WCA Marine Science, and today I'm going to be doing a tutorial for you on the portfolio from Unit 4 Lesson 4, creating a phytoplankton. So I'm going to modify this just a little bit, only in that I'm not requiring that the plankton that you make be a phytoplankton. You can make a zooplankton if you want to. Either one will be fine because in this unit we're learning about both phytoplankton and zooplankton. So, either one would be acceptable. So what you need to do is you need to design a plankton. And in order to do this, you should know something about different types of plankton, phytoplankton and zooplankton. Remembering that phytoplankton are plant-like plankton and zooplankton are animal-like plankton. These are not plants and animals. They're actually protists, a different kingdom of living things. But they have characteristics of both plants and animals, which is how they've been classified as such. So for example, a phytoplankton would have chloroplasts and do photosynthesis, whereas a zooplankton would not. And actually, interestingly enough, there are phytoplankton that are both photosynthetic and they also are consumers. So they do both in the microscopic world of plankton. So the idea is that you're going to both drop your plankton in the air and in the water, and it doesn't have to be the same height. So you can have two different heights in the air and in the water. And what you're going to be doing is you're going to be judging how fast it drops in the air versus how fast it drops in the water. It's obviously going to drop much faster in the air than in the water. Because you don't have the buoyant force of the water pushing up on your plankton. But what I would really like you to do is to be able to design your plankton in a way that makes sense according to what we see in the natural world. Okay, so you're going to be using household materials to do this, and I'll kind of give you an idea of what I did and what I'd like you to do at this time. So what I did was I researched different types of plankton, and I came up with a type of plankton, a type of phytoplankton called a dinoflagellate. And here is a diagram of my dinoflagellate. And this is something that I found online. And one of the details of this dinoflagellate, which is true about all dinoflagellates, is that they have a, I'll go this way. They have a shell, of silica. Silica is pretty much glass. So instead of having a shell made of calcium carbonate, which is what most, clams and oysters and things like that are made of, it's made out of silica, which is like glass, which is kind of interesting. They have chloroplasts, so they do photosynthesize, but they also are able to consume other things as well. They tend to move up and down the water column, so they're floating kind of a little further up during the daytime in order to be able to photosynthesize, and then they move down at night to be able to feed on some of that marine snow, the dead stuff that falls down during the nighttime, and actually be able to feed on other things at that point in time. They also have two flagella. They have a transverse flagella, which is located right here, right at this central groove that they have. And then they have their, so this provides forward motion and spin. The other one acts mostly as a rudder. It's called a longitudinal flagellum. And this is going to kind of provide them the ability to change direction and move. Okay. So this is my dinoflagellate. I picked him. And the more specific one that I picked a species, Paradinium dinoflagellate. And I actually went on YouTube and found a little video clip of my Paradinium dinoflagellate. Oh, I'll just move my box here. Because I wanted to observe how this organism moved. Because one of the questions it's going to ask you is, how does your organism move? What kind of adaptations does it have to move around and get food and things like that? And without, actually observing it, I really didn't have any idea of how to visualize its motion. So I'll play this here for you just You can kind of see a little bit of its motion. You can definitely see that longitudinal flagella moving around in the back. It's acting as a rudder so it can change its direction. Okay. Kind of allows it to steer a little bit. But then when it twists and turns and moves around, that's more the transverse flagellum that's doing that. Harder to get it into focus here, but you can look and see the transverse flagellum there. And saw another one kind of come up and bump up to it. And you can sit here and watch this video clip and kind of see a little bit more about how it moves as you move through the video clip. You know, we can kind of fast forward it a little bit and see some more motion. Here's a better picture of the motion. You know, as it starts to kind of move a little bit more and rotate. There we can see the rotation. So that gives me a good idea of what this particular Dinoflagellate looks like and moves like. So now I got to build myself a copy of this, and this is where we're going to get to kind of the actual experiment part here. So I'm going to go ahead and take the camera and lower it down to my desk and see if I can. I really wish I could do this. There we go. Zoom in a little bit more on what I got going on here. But let's make it bigger. And I have a vase of water, actually. I don't know if you guys can kind of see that, but I'll come down here and try to go sideways and you can see the vase of water that I have. Okay. So I used a vase because in the instructions it says to use your pool. My pool, well, that I don't have a pool, actually, but it is actually, if I had a pool, it would be all winterized at this point anyways. We're not living in Florida. Remember, this is a Florida virtual school class, so you tend to get some directions that are specific to Florida, which we are not in. So for this one, that doesn't really help too much, does it? No, not really. But what we're going to do is, I'm going to show you first of all the Dinoflagellate that I built. So what I used here is just a cap. I used a cap from a Tide stick. What else I have on here, as you can see, let me see if I can focus this a bit better. What else I have on here is I put a green line to represent the chloroplast. I have a black line that runs this way to represent that central groove. And then I have my transverse cilium right here. It's hard because these guys are getting tangled together a little bit. But this runs along the central groove. Okay, so this is the one that would be responsible for twisting and turning motions of my Dinoflagellate. And then I have my bottom flagella, which is the longitudinal flagella, and that's going to be giving it the rudder motion. Also, some Dinoflagellates have like an eye spot on them, and they are able to actually be able to detect light. So I drew an eye spot on the top. It's a big one, but it's an eye spot. Okay. So what I used was I filled this with like a putty because it was too light all by itself. And remember, these things don't want to just float at the top unless you have like a diatom or something, which they do just float at the top. Many of these things are you're going to want to have them be able to sink down a little bit and float back up and not sink all the way to the bottom. Okay. So you're going to time how long does it take to sink. And in this case, we're just going to look at how long does it take to sink down and then float back up. Okay, and if I had a timer, and I can use my smartphone for this. Okay, so I'm going to go ahead and put the stopwatch function of my smartwatch on. It's my smartphone, excuse me, on. And as soon as I drop this, I'm going to hit start. And I think that what I'm going to do is I'm going to drop it from let me see if I can back out of here because this is zoomed in a little bit right now. I'm going to drop it from maybe, the same height above every time. Okay, I have a problem here. There we go. I had a little bit of a video that started playing in the background. So I'm gonna try to drop it from the same height every time. About, I don't know, for me it's about like 1/5 above the glass face here. So as I drop it down, I'm gonna like 1, 2, 3, and then start my stopwatch. And then as you can see, it's sunk and then floated back to the top. Okay. So you're gonna wanna, it's not gonna be, you're gonna do that 5 times. 1, 2, 3. You can experiment a little bit with this, You can start from a little higher height if you want. But make sure you do the 5 trials all the same. Okay? So a good zooplankton would have the ability to sink down and then float back up. Ideally, if my zooplankton could stay kind of beneath the surface a little bit, rather than floating back up, it actually stayed down there. So I could increase the, density of this, maybe add an extra piece of putty to it and see how that affects it. You really need to play around with this a little bit. See, there we go. Now it's sinking all the way to the bottom. But it sunk really slowly. So adding an extra piece of putty maybe was helpful. You can see it has less buoyancy, so it's going to be able to sink down a little bit better. The idea here is that if it's too buoyant, then the dinoflagellate's not going to be able to get down far enough in the water column to be able to eat the food that's down there. Okay? So again, you're going to do this 5 times in the air, 5 times in the water. And then what you're going to be doing is you're going to go and you're going to, let me go ahead and switch back to screen mode here. You're going to write a paragraph and describe the plankton. We kind of talked about that a little bit. Tell me which plankton you based yours on and what does it need. My plankton needs to photosynthesize. My plankton needs to be able to eat food in the water column. It sinks down during the night. Just kind of give a general description of the type of plankton and what kind of adaptations it has. You also need to take a picture. You need to take a picture of your phytoplankton or your zooplankton with yourself. So I would go ahead and say, hey, here's my plankton and me, and send that along with your lab report for this one. And then after, you're going to do this data table, right? Testing it in water, testing it in air, making a data table to show all 5 trials and the times of those trials. And then once you're done making that test is when you're going to make that paragraph and description. So basically, you're going to describe how you built it. That's the first step. So give me detailed instructions on how you built it. Take a picture of it. Drop it. Test in air, test in water, and then do the paragraph describing the plankton, talking about what the plankton looks like, what kind of size would it be in real life, and that kind of thing. All right, so all of that together is what goes into this portfolio. And if you have any questions or concerns, feel free to give me a call at extension 2204 or send me a webmail message. Thank you.